Okay, so here's the problem we're going to work today. This is the first example problem. You can see it's a simple truss. It's internally stable and it's externally stable. So we're ready to go. Following the process we just discussed a minute ago, what I would do first is draw a three-body diagram of the whole structure, find the reactions at A, the reactions at C, and then go back and look at the three joints, A, B, C, and determine the three bar forces. So I guess the first step would be to find the reactions. So I'll do this here. First, I will assume that I have a reaction AY and AX, and then one here also at C. So how do I find my reactions?
Assume the moments at A.
Yeah, I think it's a good idea. So again, I'll assume right-hand rule for my sign convention, and we'll sum moments at A. Make sure it's in equilibrium. So AX and AY create no moment about A. CY creates positive or negative moment about A. Positive. So I'll have CY times its moment arm, which looks like 5 meters. And then I have this load out here on the far right. That's creating what kind of moment about A? Negative. So that's 60 kilonewtons. And its moment arm looks like it's 10 meters. So therefore CY is equal to 120. Look reasonable? And I got a positive value, so it's acting up. Any questions about that? Okay, so let's sum forces in the Y direction. Make sure they're in equilibrium. So I have AY up, CY up, 60 kilonewtons down. So that's AY plus CY minus 60 kilonewtons. So what does that require AY to be?
0.
No.
That is minus 60.
Minus 60.
I want to do before.
Minus 60. So does it make sense that AY is down?
Sure.
Well, think of this thing as a weird seesaw about C. If you put a 60 kilonewton person on this side acting down, you better have a 60 kilonewton person on this side acting down to balance it. That makes sense. So finally, we'll finish this off by summing forces in the X direction. And the only thing we have is AX, so it's in this problem it's 0. So I'll just put a little break here, and now we'll work on the bar forces. So where would you like to start? A, B, or C? Well, let me ask you this question first. Is there any joint we cannot work first? Well, there's how many unknowns at B? 1, 2. 2 equations, 2 unknowns. Same thing at C, same thing at A. So there's no one that we can't work, but there are ones that we probably don't want to work, and that would probably be B. If we're assuming XY in this convention, then both forces will have X components and both forces will have Y components. So you'll have to write simultaneous equations there and solve those. Not impossible. You can do it, but you don't want to. You want to probably start at A or C and then go to A or C, whichever one you want to start with. So I'll do it alphabetically. I'll start at A. So here's my three-body diagram for the joint at A. There it is. Pretty exciting three-body diagram. Had to work hard on it. Now what's acting on A? Well, AX is 0, AY is negative 60. So I'll draw that down. as 60 kilonewtons. And then I will assume my bar forces are in tension. So I'll have the force in AC and the force in AB. And what is the orientation, the geometric orientation of that force? It looks like I have a run of 10 to 5, so that's a 2 to 1, right? So 2 to 1. So now let's begin. Which will be the easiest equation to solve first? Some force is X, some force is Y. Yes, some force is in the Y. Only one force has a Y component. So that's one equation, one unknown. If I did X first, I'd have one equation in two unknowns. So let's sum forces in the Y direction first. So I'll assume up is positive. We'll sum forces in the Y, make sure they're in equilibrium. So what is the X component? The Y component. By the way, if this is 1 and this is 2, what's the hypotenuse? Square root of 5. Remember that? Pythagorean theorem? So my X component, my Y component would be 1 over the square root of 5. And it's acting up, so I'll say 1 over the square root of 5, my force AB, minus 60 kilonewtons down. So I should be able to find my force in AB. What is it? It's 60 times square root of 5. What's that? 132.7, I'm guessing. This is the point in the program where you get your calculator out and you calculate this.
134.2.
134.2. Anybody else get that? 60 times square root of 5?
Yes.
134.2. And that would be in kilonewtons. And we got a positive value. Positive means tension. Does it make sense that AB is in tension? I think so. That seems good. So now we can come back and we can sum forces in the X direction. I'll assume to the right is positive. We'll make sure they're in equilibrium. So our X component of our force is 2 over the square root of 5. And that's the force AB. Plus our force in the AC direction. And we have no applied X forces. So we're done. So you should be able to find the force in AC. So it should be, I think it's going to be 120. But it's going to be negative 120. I'm guessing, but tell me.
Yeah, it's negative 120.
I'm a good guesser today. So, does that make sense that AC is in compression?
Yes.
I think as this force pushes down, is point C going to move to the left or move to the right? What do you think? Yeah, so it moves to the left. That means AC gets shorter, compresses. So you can actually think of how the structure might move to help you see compression and tension. All right, so I'll go ahead and make a little squiggle here. I know this one, and I know this one. So I just need to find BC. Where's the best place to find BC? Joint C or joint B? I still go for joint C. So let's do joint C. There's my free body diagram for C. Again, very sophisticated. I'll put my reaction on there. I found CY to be 120. So there's my 120 kilonewtons. I already have a tension force that I've defined in AC, and I'm going to assume a tension force in BC. And then looking at this BC component, what's its slope? It looks like 5 to 5, so that's 1 to 1. So that means the hypotenuse is square root of 2. So I should be able to get my component from there. Now remember, I already have AC, right? I'm trying to find BC. Can I find BC with one equation that does not involve AC?
CY.
Yeah. Some forces in the Y direction. I think that's healthy for your solution process, because if you don't have to use previous information, it will be good for you. If the previous information happens to be incorrect, it would be bad for you. So let's look at the vertical component. So that'll be 1 over the square root of 2 times the force BC. That's acting up. We also have acting up 120 kilonewtons. So I should be able to find the force in BC. Whatever 120 times the square root of 2 is, it looks also it's going to be negative. So what is that? 200?
169.7.
169.7. That's it. Now what I could do at this point is I could now sum forces in the x direction with BC and see if I get the same value for AC that I got over here. So let's just do that as a check. So now I can say as a check, see if I'm in the right direction, I'm going to sum forces in the x direction. So I have AC to the left plus 1 over the square root of 2, my force BC. So what is the force in AC equal to?
120.
It looks like it's going to be negative. Well, I got BC as negative. Yeah, so it's going to be negative 120, right? Well, that makes me feel pretty good, because now I got the same, kind of independently, I got the same value that I had gotten from a different joint. So I feel pretty good about those numbers. So any other questions about this problem? No? Okay.